Hi guys. So I was thinking about what would be the most helpful for you. Um, and I thought making videos over practice problems that we had for homework. So I would just collect them for completion grade, and you would have to, you can watch the videos to see if your answers are right, to kind of go over it. Because I'm going to be out for this week. I haven't, I just got into your class. And so I'm trying to find ways so we can get done with this kind of review and then we can move on. Okay. So we did these partial fraction decompositions in class, and you had this assignment. This is PP 2.2.3. It was supposed to be due this week, but I'll collect them when I get back so you can check your work while I'm gone. Let's see. The funsies, the two funsies that I had, I'm not going to give you the answers, but maybe I'll give you a hint to how to do it. So let's go ahead and get started. So number one, remember there was two ways to solve these. 1 over x squared plus 5x plus 6. Let's go ahead and split this up. A x plus 3 factor, b x plus 2. So once you do that, we can now have a common denominator, x plus 3, x plus 2. And to create this fraction into this denominator, we know that we have to multiply by x plus 2. Multiply top and bottom by x plus 2. So a times x plus 2 over here. What's missing is the x plus 3 right there. So we're going to multiply by x plus 3, x plus 3. So that's plus b times x plus 3. Perfect. Now we can set that whole numerator equal to each other, or more specifically, this right here equal to 1. Okay, so that's a times x plus 2 plus b times x plus 3 equal to 1. Now, for this, we can do trial and error and try to figure out x's where it would make this entire term, the b term, 0, or a term 0. And that would be, first, let x equal -3. Then we're going to have a times -3 plus 2 plus b times -3 plus 3 equals 1. And this implies that a times -1 plus, and this is 0. 0 times b is going to be 0. Is going to be equal to 1. So that means this implies that -a equals 1, which implies a equals -1. Okay, now we have to find what would cancel out the a right here. So that would be let x equals -2. So let's go ahead and substitute that in. -2 plus 2 plus b times -2 plus 3 equals 1, which implies that a times 0 plus b times 1 equals 1, implies b equals 1. So we have the answer to a and b. Let's go ahead and put it back in. So we have 1 over x squared plus 5x plus 6. Turn off some notifications. Equals, so a, what was a, was -1. So -1 over x plus 3. We don't really need those parentheses, do we? X plus 3 plus b, which is 1 over x plus 2. Now remember, there is the algebraic way where we could take this right here and actually solve it with algebra. And I'm going to do it that way because, hey, stuck in my room, I've got all the time to do this. A times plus 2, b, x plus 3 equals 1. And then let's go ahead and distribute ax plus 2a plus bx plus 3b equals 1. And then let's go ahead and group the a's together. Ax plus bx plus 2a plus 3b equals 1. This implies, and then let's go ahead and factor out an x. A plus b plus 2a plus 3b. Now, remember the example that I did in class, it had a clear coefficient for x and it had a constant. This is different. It just has a constant. So whereas if we had something like a plus b and x plus, I don't know, c equaling something like 2x plus 1, then I said that, hey, 2 is going to be a plus 1, 1 is going to be c. But we don't have anything like that. We just have a constant here. So how do I change this constant into something that looks possibly like a linear function or a linear equation? If you realize that this 1 is not just a 1, it became 1 from something. And I can create that other like kind of invisible or like redundant part of that sentence. And so if you understand that 1 is the constant, it's going to be a plus 1. And there's going to be an x. I'm going to tag on an x to that. But what makes x go away? When you multiply it by a number, my favorite number, which is 0. 0 is my favorite number, okay? I call it the great equalizer because no matter what you multiply by it, it becomes 0. It has no stereotypes. Okay, so we have now set this up. Now we have a plus b is going to equal 0. And then we have, I don't want to use lime green. Let's go ahead and use this pretty. And then we have 2a plus 3b is going to be equal to plus 1. So we have a plus b equals 0. And then 2a plus 3b equaling positive 1. So that's going to be a equals negative b. Go ahead and substitute that in. Let's go ahead and put 2 times negative b plus 3b equals 1. Okay, no arrows. I'll get in trouble for this. This implies. I know, I'm used to doing arrows too, but I need to start writing things in IB. Okay, and then that would be b equals 1. Isn't that what we got earlier? Yes, yes, yes. And then when I put it back into here, that would be B. So A equals, this implies that A equals -1. A equals -1. Yep. Same thing. So it's up to you which way you want to do it. Okay. Let's get started. I'm going to use the algebra method because algebra is my thing. Up to you guys which method you want to use, but I'm gonna try to stick with that. Okay, so your answer would be, if you want to put a final answer, that would be it right there for number 1. Number 2, so we had 4 minus x over x squared plus x minus 2, x squared minus x plus x minus 2. Okay, just making sure. Okay, so we had something like this. We're gonna have this, have an A and a B. Now, the number of terms is not determined by just me just writing it down. It's actually determined by how many factors it could possibly have. So if I factor this is going to be x plus 2, x minus 1, and so x plus 2, x minus 1, you have 2, and then that's going to equal A times x minus 1 over x plus 2. And I want you to really think about what you're doing right here, because we get into this like pattern of just writing things down, but then we really don't think about it. Okay, so I have to make sure that you guys understand that to get to here, okay, which I did it incorrectly, see, because I was doing it too quickly. Let me go ahead and write it this. What I'm trying to do here is trying to get this denominator to equal to the individual fractions, to have this common denominator, right? So x minus 2 right here, x minus 2. So it needs to include that x minus 1. So I multiply x minus 1, top x minus 1 by bottom. And that's where I get this A times x minus 1. Same for here, x plus 2 times x plus 2. So we have plus B times x plus 2. Okay, now I'm going to take this and this. That is going to be my numerators that I set equal to each other. 4 minus x equals A times x minus 1 plus B times x plus 2. Let's go ahead and distribute this. Ax minus A plus bx plus 2b minus A. Checking my work. Okay. That's going to be equal to 4 minus x. This implies that 4 minus x equals ax plus bx minus A plus 2b. Let's go ahead and factor out A plus b minus A plus 2b equals 4 minus x. Now, let's rewrite this. Negative x plus 4. What's in front of the negative? There's a number there. We just leave it off. Let's let it live. Okay, I don't know what's wrong with putting a -1 there. What's the big deal? I mean, it's not that. I mean, when I taught Algebra 1, I had no problems. You know, -1 is there. We just get too sophisticated and leave numbers off, but we need to understand that it's there. So I don't know, too sophisticated. Were we ever sophisticated in doing math? Okay, so let's go ahead and figure out what equals what. a plus b goes with the -1. And use my negative a plus 2b equals +4. So we have a plus b. Okay, therefore, a plus b equals -1. Negative a plus 2b equals +4. Let's go ahead and, hey, we could just eliminate the a. So we have 3b equals 3. Divide both sides by 3. B equals 1. Yay, yay. Found b. Now let's go ahead and find a. This implies to put b equals 1 in there. A plus 1 equals -1. This implies -1. A equals -2, right? That should be right. I should really check these because I could probably get it wrong. You know, just because I teach math doesn't mean that I'm just like know everything. X squared plus x minus 2 equals a. I got -2 over x plus 2. And then for b, I got 1 over x minus 1. Let's go ahead and check that one. So that's going to be x plus 2, x minus 1 over -2 times x minus 1 plus x plus 2. And then we have, see what's happening is that you're creating this exact same numerator right here, which is what you did right here. And you're trying to figure out, look at it. Look at the exact same, it's the exact same pattern as what you wrote down right here. See, right there, or like right here, actually right here. You see, right there. And so, and it works out perfectly. Okay, so while I was saying that, 2x plus 2 plus x plus 2, negative x plus 4. Voila! If I turn that back around, rewrite it. No, I shouldn't put implies. I don't think you're supposed to put implies there. This is 4 minus x. And that would be the numerator. Bam. Okay, so that would be the correct answer. I know you're not supposed to box answers, but to show you in this, the way that it flows, I did a lot of other things. Let's check this one. I think this one's right. Just have a sneaky feeling. You know, I'm going to check it later. Well, if you discover. Okay. I actually checked the one, number 1 in my head just now while I paused this video where I took a little break. And it was right. It was -1 and 1. And it's easily checkable because you just have to take that denominator right there, x plus 2, and then, you know, distribute the negative and then add the x plus 3 to it. Anyways, on to our next problem. Yay, yay. Let's go ahead and find the factors. Here we go. X minus 3. A. X plus B. X minus 3. Does it equals? Does it equal? I don't know. Let's go ahead and do A. X minus 3 plus B. X times x over x times x minus 3. There we go. And then we have the numerator equaling this numerator. And so that's 4x minus 9 equals a times x minus 3 plus bx. Let's go ahead and distribute ax minus 3a plus bx. 4x minus 9. This implies,
that 4x minus 9 equals, I'm going to take that and group them together. The a's together, factor out the a, x plus b minus 3a. 4x minus 9 implies, there we go, a plus is 4, minus 3a is negative 9. So let's go ahead and do a plus b equals 4 and negative 3a equals negative 9. Notice I took the entire sign, and then I just want it to be a plus and a plus. I just wanted to leave that plus behind and just make it all pluses because, you know, we're not actually subtracting numbers together. We are adding negative integers, right? Okay, so divide both sides by negative 3. And this implies that a equals 3. Okay, let's go ahead and substitute it into the first equation. This implies that 3 plus b equals 4, which implies that b equals 1. Let's go ahead and rewrite it. That shows a 3 in a, so 4x minus 9 over x squared minus 3x actually equals 3 over x plus 1 over x minus 3. Now to check, equals x times x minus 3, 3 times x minus 3 plus x equals 3x minus 9 distribute plus x times x minus 3. This equals 3x. No, what am I doing? 4x plus 9. Yes, yes, yes. I mean minus 9. X times x minus 3. Yay, yay. So I had the right answer. There you go. Good job. If you got it right, give yourself a pat on the back. Yay, yay. Okay, number 4. Number 4 is x over x squared minus 1. This is a difference of squares. How do I know? We have an x squared and a 1. Those are perfect squares. Perfect squares is a number. When you multiply the same number together, it gives you that number. It's perfect. Perfect squares. I mean, you're made up of your factors are identical. Hey. Okay, so we have a, x plus 1, plus b, x minus 1. And how do I factor perfect squares? You take the square root of this, you take the square root of that. That's x and 1, x and 1, and it's going to be always a plus and minus, right? Right. Okay, so we have a, x minus 1, plus b, x plus 1. Our denominator, now we can combine x minus 1. Okay, now we have this numerator x is going to be equal to this numerator. X equals a times x minus 1 plus b times x plus 1. Okay, let's go ahead and distribute ax minus a plus bx plus b. Let's go ahead and consolidate or group together. My throat's getting scratchy. Take out the x. I should have bought some, I don't know, shares in cough drop market. Never thought about how important cough drops are until now. Okay, now, so what we have here is just the x. See? X has to be multiplied by a plus b. What's hiding is this 1. And then we can rewrite this and it'll be plus 0 right here. That constant's going to be 0. 0 is an actual number. We just leave it off because we're just like, hey, we don't need to mess with it anymore. But then you need to make it reappear sometimes. Okay, so a plus b is 1. And negative a plus b is 0. So I had to go back and forth and figure something out because there was some kind of discrepancy with the software that I'm using, and kind of messed it up. So let's see. So a plus b equals 1, and then negative a plus b equals 0. Let's try using this. Kept on messing up with freehand line. No, freehand. It doesn't have all the colors, does it? Erase. What happens if it says erase? It doesn't erase. But anyways, okay. We can test this out some other time. So I'm not going to use that. Okay, so I could use elimination. And it's going to be 2b equals 1 and b equals 1/2. So we're going to have a little fraction for the numerator, which is kind of interesting. Okay, so let's try to figure out what a is, and then let's try to figure out ways we can write that. So a would be half. So if b is 1/2, and you add 1a to it, and you get 1. So a would be 1/2. Right? Half and half equals 1. Okay, so if I rewrite this, x over x squared minus 1 equals, you're going to see something like 1/2 over x plus 1 plus 1/2 over x minus 1. And then you get a compound fraction. But who wants a compound fraction for their final answer? Do you? Not me. You shouldn't. So what is a good way to actually maybe have a multiplier in the front? I could take out a 1/2 there, right? And I would have a 1 over x plus 1 plus 1 over x minus 1. Couldn't I write it like that? That would be the same thing, right? So I could make that my final answer. Good job. Number 5. Number 5. I'm redoing this. So number 5 says 5 over negative x squared minus x plus 6. Let's go ahead and factor this. Negative x and then x. It's going to be a negative and a negative. And then 3, 2, 3. 3 here and 2 here. Is that right? Negative x squared, positive 2x minus 3x, positive 6. Bam, bam. Is that right? Yep. Positive 2x minus 3x plus 6. And then we have an a and a negative x minus 3 and a b and an x minus 2 equals a times x minus 2 plus b times negative x minus 3 over negative x minus 3 times x minus 2. Once again, we're going to take that 5 and have this entire numerator equal to it.
So we have 5 equals a times x minus 2 plus b times negative x minus 3. Go ahead and rewrite this as 0x plus 5, ax minus 2a minus bx minus 3b. Rewrite ax minus ax minus bx minus 2a minus 3b. And then, you know what I just remembered? I didn't check the last problem. But I know it's right because I just do. Okay? 2a minus 3b equals 0x plus 5. But you should always check. Okay? Now, we have a minus b. Ooh, that's a bad combination right there. We have an a minus b equaling 0. And we have an a minus negative 2a minus 3b equaling 5. We have an a minus b equaling 0. Negative 2a minus 3b equaling 5. We'll go ahead and set a equal to b, right? And then go ahead and substitute. Let's just go ahead and substitute that for 5. And b equals negative 1. So therefore, a equals negative 1. So we have 5 over negative x squared minus x plus 6 equals negative 1 over negative x minus 3 plus, no. Oh, we could write it, we could start it like that. And then negative 1 over x minus 2, or we could do this. Sorry. And then we can have negative 1 x minus 3 minus 1 x minus 2. That would be the final answer. Okay? You can check. You can do negative 1 times x minus 2 minus 1 times negative x minus 3. And that should give you 5. Negative x plus 2 minus plus x plus 3 cancels out the x's, and plus 2 and plus 3 give you 5. There is your answer. Good job, good job, good job. Or if you want this one. Good job, good job, good job. Number 6. I always end up picking that pink color. Green. We have 11 plus 3x over 6x squared plus 5x minus 6. Let's go ahead and start out by factoring. Ba-bam, ba-bam, plus, minus. We have 3x and 2x. Let's just go ahead and test that out. 3, that's going to be 9. 2, that's going to be 4. 3, 2, that's 9. 4, 9 minus 4 equals 5. Yes, yes, yes. Is it the right sign? No, no, no. It'd be negative. So, ba-bam, ba-bam. We have minus 2 and plus 3, right? Plus 9 minus 4. Plus 9 minus 4 equals positive 5. Yes, yes, yes. Okay. Going to be a over 3x minus 2 plus b over 2x plus 3. And it is going to equal a 2x plus 3 plus b 3x minus 2, and our common denominator is 3x minus 2 and 2x plus 3. Okay.
let's go ahead and take that numerator. Ooh, not a good color combination. Let's make it yellow. Yellow goes with everything. There we go. With this right here, that numerator. And then we have, I'm going to rewrite this in standard form. 3x plus 11 equals a times 2x plus 3 plus b times 3x minus 2. So we have, we have a 2ax plus a 3a plus a 3bx minus 2b equals 3x plus 11. Let's gather up the x's. 2ax plus 3bx plus 3a minus 2b. Collect the x. 2a plus 3b plus 3a minus 2b. That's going to all be 3x plus 11. Okay, so we have 2a plus 3b, 2a plus 3b equaling 3. And 3a minus 2b equaling positive 11. 3a minus 2b equaling 11. What's the best way to solve this? I'm going to solve for this b right here. Why? Because this is divisible by 3. Or I can use elimination. I'm going to try doing that. I'm going to multiply this by 2, multiply this by 3. I had to get rid of that arrow because it's not an arrow. It implies that for a is it plus 6b equals 6. Kind of lose my train of thought sometimes. 3 times 2 is 6. 3, 6. 3, 3, 9. A minus 2, 3, 6. B, and then 33. Okay, there we go. We're going to add together. That is going to be 13a, cancels out the b. And then at this point, you tell yourself, please work. Please work. Please. Make it an integer. Please. 39 divide by 13. A equals 13? No. That's not how division works. That's not how division works, Miss Alstrom. Okay, I think that's 3. See, right? 9, 3. Okay. Once you have that figured out, you're going to put it back into one of the equations. 2 times 3 plus 3b equals 3. 6 plus 3b equals 3. And then let's subtract. This employs 3b equals negative 3. And so b equals negative 1. Employs. Okay, now we have our a's and b's. Where's the original problem? Let's go ahead and look at where it went. It went all the way over here. Let's go ahead and rewrite it. 11 plus 3x over 6x squared plus 5x minus 6 equals, we had a, which was 3. That. And we had our minus 1, well, just 2x plus 3. Some of you guys are going to have the negative 1x first because you use that factor. Use the 2x plus 3 factor first. So just that numerator, negative 1, has to go along with it. So it might be switched. What I mean by that is it could be look like something like this. It's the same thing. That would be, is it the commutative property? That's an associative property, right? No, that's a commutative property. Your mommy as your daddy is the same thing as your daddy as your mommy. Okay. But anyways, yeah, it's the same thing. Okay. And then let's go ahead and check. Okay. So I had 3 times 2x plus 3 minus 1 times 3x minus 2. And I had 6x plus 9 minus 3x plus 2. So that is a 3x, 6x, and minus 3x plus 11. Voila! That is my final answer, and there you go. What's next? What's next? What's next? Numero 7. Okay, let's go. Let's go. Number 7. 10x minus 1 equals 8x squared plus 2x minus 1. Let's go ahead and factor this. Plus and minus. We have a 4x. Is that a perfect square? I mean, differences. No, not difference of squares. No, I mean, it can't be. No. What am I thinking? Okay. So let's try 4x and then 1 and 1. No, that's not going to work because it doesn't work like that. Nope. Nope. No, it's not going to work. Okay. Let's see. 4. That's not 4 and 4. 4 times 4 is 16. Wow, Miss Alstrom. Okay, so yeah. Feel like it's not working out. 4x and 2x, right? 4x, 8, negative 1. 2 times 4 is 8, right? And then 4, and then minus 2. That works. Okay. Let's see. Okay, next. This is going to be equal to a and 2x plus 1 plus b 4x minus 1, a times 4x minus 1 plus b times 2x plus 1. It's going to be 2x plus 1, 4x minus 1. There we go. So let's get that. Lilac equaling 10x minus 1. Oh, do I have that lilac color? What are these? These new colors that they've added? Whoa. It's like gold. Oh, I've seen that. Okay. So we have 10x minus 1. Oh, I don't like that. I don't know. I don't like that. Let's pick some more colors. I like those pretty purples. Okay. 10x minus 1 equals a 4x minus 1 plus b 2x plus 1. It's taking me a long time to make these videos. I have to pause it so many times when I cough. Okay, so let's go ahead and 4ax minus a plus 2bx plus b. Okay, I'm kind of getting sick of that color. 10x minus 1 equals, let's go ahead and group the x's together. Yes. Plus 2bx minus a plus b. We have x and then 4a plus 2b minus a plus b. By the way, I remember somebody that is not subscribed to my, that's not one of my students, watched one of my YouTube videos and commented and said, I like your accent. I'm like, what accent? Right? But anyways, yeah, I just make voices, but I don't have an accent, right? Right? Well, if I do, so what? Okay, just saying. 4a plus 2b equals 10. And then we have negative a plus b equals negative 1. Okay. Should we do substitution or should we stick with elimination? I think I'm gonna do b equals a minus 1. Okay. So we have 4a plus 2, a minus 1 equals 10. I substituted this a minus 1 and for b for the first equation right here. A plus 2a minus 2 equals 10. 6a equals 12. A equals 2. And then let's figure out what b equals. B equals 2 minus 1. B equals 1. Ba-bam. $10x minus 1 applies. So therefore we have 10x minus 1 over 8x squared plus 2x minus 1. This equals 2 over 2x plus 1. And then we have plus 1 over 4x minus 1. I think that's correct. 2 times 4x minus 1 plus 2x plus 1. That's 8x minus 2 plus 2x plus 1. That's 10x minus 1. And it checks out. And there's your answer. Yay! Yay! Good job. Last one, number 8. We have x minus 1 over x squared plus 8x plus 15 equals a over x plus 5 and 3, x plus 3, x plus 5, x plus 3, a times x plus 3 plus b times x plus 5 over x plus 5 times x plus 3. Okay. Take x minus 1 and then set it equal to that entire thing. So we have x minus 1 equals a x plus 3 plus b times x plus 5. Go ahead. This implies x plus 3, bx plus 5b, x minus 1. This implies x, gather the x's together, factor it out, plus 3a plus 5b, x minus 1. And then we can set them equal to each other. So x minus 1 equals a plus b. And oh no, what am I doing? 1 equals a plus b. There's a 1 right here. And negative 1 equals 3a plus 5b. So therefore that implies that A equals 1 minus B? Do I want to do that? Okay, why not? And so we're going to substitute. That implies negative 1, 3, 1 minus B plus 5B implies that negative 1 equals 3 minus 3B plus 5B. Negative 3, negative 4 equals 2. 2B. B equals negative 2. Right? B equals negative 2. So what does A equal? This implies when we set that equal negative. Let B equal negative 2. And A equals 1 plus 2 implies that A equals 3. Okay, so let's gather it up. X minus 1 over x squared plus 8x plus 15 equals 3 over x plus 5 minus 2 over x plus 3. And then we can check 3 times x plus 3 minus 2 times x plus 5, 3x plus 9 minus 2x minus 10. That's going to be give me x, and that's going to give me a minus 1. Voila. Good job. So the thing about the extra credit, okay, is that you got to think about it. If you have a denominator of x plus 1 cubed, it could come from a lot of things. Remember, this could be made up of an x plus 1 and then an x plus 1 cubed. Remember, because there's one of x plus 1s and there's 3 factors that are x plus 1s. So the common denominator would be x plus 1 to the third. It could also be made up of x plus 1 to the second plus x plus 1 to the third. It could be made up of those two denominators. But you have to think of every single possibility. So every single possibility would be one of these, two of these, and 3 of these. And depending on whether you actually have a value for the numerator, an actual value that's not 0, it tells us that the original fraction had those factors as denominators. So if you had a 0 here, that would not exist, but then it would give you a 0 there once you do your systems of equations. Okay? Good luck with that. Bye, guys.